How to compensate for the magnetic compass. In the age of GPS and satellite positioning, the magnetic compass remains the only autonomous navigation instrument that does not depend on electrical power or external signals. The total force is vectorially decomposed in two directions, one the horizontal H and the other the vertical Z. The most important one is the first H, which is the one that orientates the compass. The angle that forms H with the true meridian in T, it is called magnetic declination or local variation. The line which joins the points with zero inclination and maximum force horizontal defines the magnetic equator. The minimum values of F are located near of the magnetic equator. The maximum values of H are in the magnetic equator and zero in the magnetic poles, and this is the reason why that the compasses which work by H have weak orientation force in high latitude and strong one close to the magnetic equator. On the contrary, Z, its value is maximo in the magnetic poles. Key concepts before starting the magnetic compass adjustment. Magnetic declination, DM, the angle between true north and magnetic north, which varies according to geographical position. Deviation, delta, the error caused by the ship's own magnetism, permanent and induced. Total correction, CT, the algebraic sum of the declination and the deviation, CT equals DM plus delta. Local variation or magnetic declination. ITS correction, it is the angle in any point of the Earth between the magnetic meridian and the geographic one, true north. Its values are in the nautical charts with the indication of the year. Ship magnetism, in the construction of the vessels there are many materials sensitive to acquire magnetism under the action of the Earth magnetic field. The acquired magnetism is classified in permanent, a lot of carbon, and induced, bit carbon. Also, there are materials which have in between permanent and induced, intermediate. Deviation, it is the angle between the compass north and the magnetic north. It is evident that if the vessels were built with non-magnetic materials, there would not have any deviation. The goal of the adjustment is to reduce as much as possible the said deviation. Different ships' headings, as there are north, magnetic, and compass meridian as reference. As a result, there are true, magnetic, and compass headings. The compass adjustment consists of its correct installation, either in or near a binnacle, of magnetic correctors and soft iron, so that their effects are equal and opposite to those of the ship's magnetic material, thus reducing deviations. The magnetic conditions on a ship that affect a magnetic compass are permanent magnetism and induced magnetism. In a nautical compass installed in a binnacle, permanent magnetism is corrected with longitudinal, transverse, and heel magnets, and induced magnetism is corrected with the spheres and Flinders bar. The longitudinal permanent magnets, B, only correct east-west magnetic headings and do not affect north-south magnetic headings, and the transverse permanent magnet, C, only corrects north-south magnetic headings and does not affect east-west magnetic headings. The induced magnetism varies with the strength of the surrounding field, the metal of the vessel, and the alignment of the metal in the field. Since the intensity of the Earth's magnetic field varies over the Earth's surface, the induced magnetism in a ship will vary with latitude, heading, and heel of the ship. The magnitude of these deviations will change with magnetic latitude changes because the directive force and the ship's vertical induction both change with magnetic latitude. The deviation resulting from the Earth's field induction of these symmetrical arrangements of horizontal soft iron are called D-deviations and are maximum on the intercardinal headings NE, SE, SW, and NW, and 0 on the intercardinal headings. These quadrantal deviations are corrected with spheres or, in Japanese compasses, with boxes containing plates inside. Procedure for adjusting the magnetic compass. Berth tests and adjustment. Before we start any adjustment at sea, we have to be sure about the following points which we have to check when the vessel is alongside. Physical checks on the compass and binnacle if there is any bubble and it is not very big, we must remove it. If the bubbles are big or there are many of them, it means that the compass is damaged and must be repaired. Remove any slack in gimbal arrangements. C/test for sensibility of the compass performed with a magnet. It is made writing down the actual magnetic heading and then approaching the magnet to the compass. If the compass does not recover the previous heading in, let us say, few seconds, or it is blocked, it means that the compass is damaged and must be repaired. D/magnetization check of the spheres and Flinders bar. Sometimes it is difficult to adjust the compass since the spheres, overall, are magnetized. For this reason, it's better to check this possibility, i.e. move the spheres as close to the compass as possible and slowly rotate each sphere separately. Any appreciable deflection, more than 2 degrees, of the compass needles resulting from this rotation means that the spheres have residual magnetism. With the Flinders bar is rarer, but if any doubt, note the compass heading with the Flinders bar in the holder, invert the Flinders bar, and again note the heading. Any appreciable difference of more of 2 degrees indicates magnetism. E/open the binnacle and see, write down, where the permanence magnets are, fore and aft, athwartship and heeling magnets. This is of paramount importance since sometimes the magnets have been changed by an unprofessional or maybe by a crew member who does not the procedure, or they have fallen because they were not protected. Important data. F/check the local variation. H/ if it is a small yacht, see the leading lines available. If the adjustment is made on a merchant ship, it will be done using a gyroscope. In this case, it is essential to verify the gyroscope error. Check it against the true heading of the dock where the ship is moored. Local interference. Check that there are no ferrous or moving objects near the binnacle. I've seen deviations simply from leaving a smartphone or portable radio near the compass. Adjustment at sea. In a merchant vessel, this is performed using the gyro, which is the best way, always knowing the error, if any, swinging from heading to heading slowly, starting, if possible, with E or W magnetic, which is normally the biggest one. 1/ the heeling magnet should be checked, though it is better not to change, only if it is too close to the compass it is necessary to lower so as do not affect the compass. Normally the polarity is read up. So, avoid the adjustment of the heeling magnet, which is quite impossible to perform in a merchant. 2/ correct the cardinal magnetic headings, starting with the east magnetic. This is the most preferable. Come to this magnetic 0-90 degree, insert fore and aft B magnets if it is the first time or it is necessary, or move the existing B magnets in such a manner as to remove all deviation. 3/ come to a south magnetic heading, 180 degrees. Insert C magnets, athwartship, if necessary, or move the existing C magnets in such a manner as to remove all deviation. 4/ come to a west magnetic heading, 270 degrees. Correct half of any observed deviation by moving the B magnets. If the residual deviation is small, leave it as is, for example, 2 or 3 degrees. 5/ come to a north magnetic heading, 000 degree. Correct half of any observed deviation by moving the C magnets. Also, if the deviation is small, leave it. On a small yacht, this is the only possible adjustment, since there are no spheres and the yacht has no induced magnetism, so you just have to check it and note it on the certificate. 6/ come to any intercardinal heading, 045 degree, and correct any deviation by moving the spheres in or out. Normally most of the vessels have spheres, plath/Sperry or caissons and plath. The Japanese compasses like Nunatani, Tokamak and Sora have instead boxes which inside there are plates to be inserted. 7/ come to the next intercardinal magnetic heading, 135 degrees, and correct half of any observed deviation by moving the sphere. Also, if the deviation is small, leave it. You can also check the two which remain, 225 degrees and 315 degrees, and write down the deviations. 8/ secure all correctors and take a photo of them and write down where are installed. This is of paramount importance to issue the new deviation card. As explained, many physical checks are essential before starting the adjustment at sea. It will save a lot of time and errors. If the compass has any small bubble, it must be filled with the proper fluid. In this case, take care since it is important to know which one is to be added. Sometimes distilled water, sometimes special fluid which normally the adjuster, if it was not advised, he will not have. If you fill with an inappropriate fluid, you can cause a big damage inside the compass. If the bubble is big, the compass must be sent to be repaired since the membrane or any seal gasket is damaged and the compass is leaking. Regarding the test of sensibility, just be sure that the compass card returns to the same reading after deflection. Correct alignment of the lubber's line of the compass with the fore and aft of the ship is of paramount importance. Nevertheless, when an adjuster goes to a vessel which has the compass already adjusted, it is assumed that is aligned. Only if the binnacle must be installed due to as a new ship, in this case the alignment must be done properly. The Flinders bar is installed when the vessel was built and the adjuster has nothing to do in this matter. Only use an empirical amount of Flinders bar, 30 centimeters. If the length is not the appropriate, the compass will have deviations in the headings EW when the vessel changes a lot in latitude, 30 degrees or more. So, the Flinders bar is left as it was and the sphere also in its position, if the compass has been adjusted previously. The B error results from two different causes: the fore and aft permanent magnetic field across the compass and an unsymmetrical vertical induced effect forward or aft of the compass. The former is corrected using fore and aft magnets, B, and the latter using the Flinders bar. Inasmuch as the Flinders bar setting has been made at dockside, any B error remaining is corrected with the permanent magnets, fore and aft. The C error has two causes: the athwartship permanent magnetic field across the compass and the unsymmetrical vertical induced effect athwartship of the compass. The former is corrected by the use of the permanent magnets B, athwartship, and the latter with the Flinders bar port or starboard side of the compass, but this error is very rare. The C error is only corrected with the C magnets. The D error is due only to induction in the symmetrical or horizontal soft iron, and it is corrected by the use, only, of the sphere's athwartship of the compass. To sum up, the discussion above reveals that certain errors are rare, others have been corrected at dockside. Therefore, for most ships, there remain only three errors to be corrected at sea: the B, C, and D errors. These are corrected using fore and aft, B, athwartship, C, magnets, and quadrantal spheres for the D error. If a ship has spheres and many permanent B and C magnets correctors close to the compass, there will be a condition of induction between these correctors which can cause the magnetism of the spheres and Flinders bar, which will create some difficulty during the adjustment. This situation can be improved by using more magnets further from the spheres and compass and using larger spheres further out in the brackets. Regarding the Flinders bar, it is generally impossible to place the corrector amount of it. The only correct way is as follows: in the position of magnetic equator the Z equals 0, and then there is not vertical induced magnetism. 1. Take out all pieces of Flinders bar. 2. When the ship crosses the magnetic equator, head to M or WM. 3. Correct all the deviation with fore and aft magnets. 4. When the ship is in other part of the ocean, around 20 degrees or 25 degrees more in latitude, head to M or WM. 5. Correct all the deviation with the Flinders bar. This will serve for all latitudes. Once compensation has been made, it is impossible to eliminate the deviation completely. Therefore, we must prepare the deviation card, a document that indicates the residual error for each heading. It is of paramount importance to have the documents, service report, and the magnetic compass adjustment certificate ready to be handed over to the captain. Only the details like the time and the deviations values, of course, will be missing and will be introduced after completion of the job. Documentation prepared by Captain ROS. Compass Adjuster number 86 for the DGMM, Spanish Administration.